Hello and welcome to another Monday night Q&A. I'm joined tonight by my colleague Dan Smith from the regional engineering team. How are you doing, Dan?
Hot.
Yeah, I was just
I've got a fan blowing on me and a pint of ice at the moment to drink, so I'm good, thank you. How about you?
Yeah, good. Yeah, it's been very hot, very unusual, and yeah, like we were just saying at the start of the day, I was thinking, oh, what are they all worried about? It's not too bad, but yeah, this afternoon it's really kicked in and gone up a notch. So yeah, quite interesting. Okay. As with all of our live Q&A sessions, I'll just run through a few house rules. We'll start off with our question of the week, which we posted out across social media channels earlier today. We'll go through our answer to that question, and then while we're doing that, we hope that you can put your questions into the chat. While you're doing that, we'll go through some of the questions we didn't get around to from previous sessions. Please put your questions in the chat as soon as you can. Remembering our golden rule: no such thing as a stupid question, only stupid answers. While you're in the chat, please remember to be respectful to each other, because the whole idea of this evening is that collectively we'll help each other with the aim of improving our collective knowledge and understanding of all things associated with BS 7671 and our wonderful world of electrical installation. So, without any further ado, we'll just remind people of our question of the week. So the question that we posted out today was, in accordance with BS 7671, the inspection of which of the following is not required when performing initial verification? And our four options given were conductor identification, conductor connection, measurement of volt drop, and the routing of cables. So which one of those four is not a requirement for inspection during initial verification? So what was our answer there, Dan?
The answer is C, measurement of volt drop. So although you find regulation 642.3 net 4 states that initial verification shall include the selection of conductors for current claim capacity and voltage drop in accordance with the design, it doesn't actually require a measurement of voltage drop. You'll also find that there's also an informative note, which is quite important, that will help answer this one, under 643.11, which actually states that verification of voltage drop is actually not normally required during the initial verification. And you will see find 643.11 will also confirm that where required to verify compliance with Chapter 52, the voltage drop shall be evaluated by measurement or by calculation. So calculation can be used. In that calculation, you may wish to refer to Appendix 4, obviously, to help calculate that volt drop as well. So, yeah, and I think another important note as well, Sam, I think to note is that obviously we're often asked, how can you expect the routing of a cable when the installation is finished and the cables are buried in the fabric of a building, for example? And it is very important to remember that 641.1 does tell us that every installation shall, during the erection and on completion before being put in service, be inspected and tested to verify, again, those famous words, so far as reasonably practicable, that the requirements of BS 7771 have been met. So therefore, the initial verification should not just be something that we do at the end, but it's actually something that we do during the whole erection process. So
yeah, absolutely, and that's something that sometimes gets a little bit lost in the translation, isn't it? In that, if we've got a small installation where perhaps the same person is the designer, the constructor and the testing inspector, then you will naturally do your inspection as you go along. But on larger installations, where it's done by different groups of people and possibly even by different companies, it's very important that initial verification isn't something that's left till the end, because by then there's lots of things that you're unable to inspect, such as cable routing and ensuring that you've got access to the required points of connection for future testing inspection. So yeah, it's very, very important that we always remember that initial verification isn't just something that you do right at the end. So yeah, a really key point, and we often get asked that when people are looking at that list of what's required in initial verification, and come up with the question, well, how are we supposed to check the cable routes when the walls have all been plastered and the kitchen's been fitted? And yeah, it's too late then, but it should have been done as part of the construction stage. So yeah, really important. Okay, so yeah, while we're giving you some time to put your questions into the chat, please, we'll just run through a few others that were hanging over from previous sessions. So number one, another technical helpline classic. In a wet room with a demountable shower head, where's the limit of zone 1? And the classic sort of follow-on question that we often get is, do I need to take the shower head off the wall and stretch the cable out to its maximum in order to start the point of where I measure my zone 1 limit? So what's our thoughts there, Dan? With a demountable shower head, where's the limit of zone 1?
So with reference to section 701, you're going to find the limit is 1.2 metres, but that's from the fixed water outlet itself. So in the case of the demountable shower head, take this point as the point from the shower head, which is considered to be the normal position for the operation. I think you'll find a regulation, 701.32.3 which will say that the limit of zone 1 is a distance of 1.2 metres from the centre point of that fixed outlet from the wall or ceiling for showers without a basin. And there's further guidance in the diagram which you find in section 701, which is, I think, figure 701.1. Which will show that demountable shower heads do not need to be considered when determining the extent of the actual zone. So, and obviously beyond zone 1, the general rules of BSM 671 apply, including the requirements for the equipment that shall be of the design appropriate for the situation. So,
yeah, absolutely spot on. So we don't need to stretch and cover all of those what-if situations. It's really based around the use, the intended use of that equipment. Okay, another one, in an existing domestic installation where we've got 16mm squared single core tails, will they be adequate if the rating of the distributor's cutout fuse is 100 amps? So again, another classic question to the helpline. We've got 16mm tails which we know won't carry 100 amps, but they're currently being protected by a D&O cutout fuse rated at 100 amps. Is that okay?
So we get this asked quite a lot. Could be, could not be, obviously. So you have to do a bit of further investigation now. So you need to consider the max demand of installation, taking into account like the load characteristics, diversity, load profiles, looking for signs of thermal overload over time as well. These are indicating signs as well, because whilst you'll find there are obviously many installations that do have 16mm tails on 100 amp cutout, been there for 30-40 years, and there's no sign of overloading, there's no issues at all that you're finding from the testing, etc. So whilst the cutout fuse would need to find adequate fault protection, this is the main thing. Does it provide that mechanical disconnect in the required time? But if the tail's been there for several years, it's just for me, it's mainly looking for that signs of overload over time, thermal damage. So what I think you should probably try and avoid is jumping in there straight away and saying straight away, no, it's got to be increase to 25mm. When just step back a little bit and just look at the whole installation, and actually just apply some engineering judgment in that. Yeah,
absolutely. And I always think about it's the situation of a spur off a ring. That spur cable is only 2.5mm. There's no way it will carry 32 amps, yet you've got it protected by a 32 amp device in the board. And it's a very similar approach. We know that on the end of that spur we can only have a single socket or a double socket if it doesn't have overcurrent protection. So we know that single spur will carry a maximum of 2 times 26 amps, which will be okay. So we can rely on the load for overload protection, and as you rightly say, that means then we're only relying on the 32 amp protective device in the board for short circuit and earth fault protection. And it's a similar approach, isn't it? We don't have to rely on the DNO for overload protection. We can rely on the load itself if we can confirm that it's never going to exceed the minimum current carrying capacity of the cable. So that's where we need to do our calculations and supplemented perhaps by measurements to ensure that we've got the right maximum demand.
And also, I think you've got the regulation, I think, under 433, which, you know, where it's the emission of device for overload protection as well. So there is actually, you know, you are permitted to do that under the BS771. Again, looking at where it can't overload the cable. So again, treating, I suppose in your case, the internal circuits, the socket at it, with the installation, you know, what by doing that max demand, looking at the whole installation as a whole, you might find that, you know, the installation is well within the cable characteristics for, you know, 16mm squared cable. So again, looking at load profile, the diversity, etc., is factoring all that in. But the main thing really is that if it has been there for a significant amount of time and there is no signs of overloading, and you do clamp test on the whole installation with everything on, and you find that it's well within the current carrying capacity of the cable, then you have to ask yourself why you're upgrading it.
Yeah, absolutely. Okay, a bit more. One that's been introduced by new changes or more recent changes. Where can I get information about what size conductors should be used for the connection of surge protection devices? So I know that I need to make connections for my earth path. I know that I need to make connections to an overcurrent protective device. But where can I get information about the size? What size conductors should be used for the connection of SPDs?
So there is actually a specific regulation that actually refers to this, and that's under regulation 534.4.10, which basically states that conductors between the SPD and the MET or the protective conductor should actually have a minimum CSA of 6mm squared copper or equivalent for type 2 SPDs, and then this is increased to 16mm copper or equivalent for type 1 SPDs as well. Furthermore, you also find that the conductors between the SPD and the overcurrent protective device, two derived conductors, shall be rated to withstand the protective short circuit current to be expected, and shall have a minimum CSA of 2.5mm squared copper or equivalent for type 2 SPDs and 6mm for type 1 SPDs.
And what about the reference to being ensuring that the conductors are sized large enough to withstand that prospective short circuit current? I can get information in 7671 about that, can't I?
Yeah, you sure can. And again, I think relating to that, you've got regulation 43452. It's got a lovely calculation, which is T equals K squared S squared over I squared, which is, to say, rolls the tongue beautifully. And that's obviously the withstand capabilities of the actual cable itself and the temperature rise, so for the current conductors under those conditions.
And that was a real light bulb moment when somebody explained that to me, that you know, when it comes to short circuit, there's no defined disconnection times like we have for protection against electric shock. It really does boil down to, is your cable large enough to carry the fault current for a time greater than it takes the protective device to disconnect. That's what we're looking for. So that's our T equals K squared S squared over I squared, which tells us whether our cable, how long that size cable will carry that particular fault current for, and so long as that's greater than the time it takes the protective device to disconnect, then it's deemed that we're meeting that thermal constraint of the cable under fault conditions. So yeah, real important calculation to get your head round.
That's saying as well that you used to refer to fault clearance time is a name that we used to refer to that calculation as well, for how long for that cable carry that fault for. Remember a tutor talked about years ago, and again it was like a light bulb moment, and like when you realise that calculation in the regulations, you then think about buzz bar chambers and, you know, smaller CSA conductors coming off of that, and how can that be, you know? But actually it's about the withstand, the thermal constraints of that cable, isn't it? So
yeah, no, it's a great and it's a great description of what it's all about. Excellent. Another one that's common as well. What should I do if I find that a TNCS system has a much greater ZE than the typical maximum of 0.35 ohms? So again, a common question, and this one's about TNCS, but we get it similar around TNS as well, obviously a different value. But what should we do if we go to an installation and we find that the ZE is much greater than those quoted typical maximums?
Yes, this is actually very popular. I've found it many times on assessments as well. Obviously, the first thing you should always do is actually advise the customer to contact the DNO, because I say it might have been inherent thing that they're fully aware of, or it might be a new fault that's developed as well, which they should be aware of anyway. That should be made aware of. So always let them know. For the installation side of things, you need to consider, well, how high is it? Is it throwing your maximum ZS values out? Is your RC protection? All these things to consider, because I think everyone gets hung up on this 0.35, 0.8 ohm value. That is a typical loose guidance value that is just inherent from Energy Network Association documents, and obviously, and I'm going to pun our new Pocket Guide app. There's actually on the Pocket Guide app, which you can download, called Guide 30. There's a lovely one on that typical values of external earth impedance. Recommended, again, the recommended value. So again, but the main thing is inform the customer, let the DNO, make them aware of the situation. But from the installation side of it, well, okay, so say you've got 0.5 as your ZE, is it throwing out your readings? Can you still achieve ADS to the final circuits? All this has got to be considered as well. So you probably find, and this has happened, where I know contractors that have called up the DNO, for example, and they're aware of a particular high ZE in a certain area, which is above the typical value, and they haven't been concerned about it at all, to be fair. So it depends on area, but equally, it could have been a new thing that's actually developed that they're not aware of, and you might see them actually take further action from that as well. So customer, make them aware from your side, from the installation side of things, look at the results. How far out is it playing the maximum ZS values out of kilt or so?
Yeah, because it could be that there's not an issue. It might be above those quoted typical maximums, but it's been slightly above them for years. It always has been, and you'll find in those cases the DNO probably won't even come out to investigate. What would cause a problem would be if it suddenly changed. Yeah, so you knew that when you installed 2 or 3 years ago it was very low, and now all of a sudden it's tens or hundreds of ohms. Then that would kind of indicate that something's happened, and the DNO would want to get involved and investigate. But yeah, it does depend very much on what it was and how stable it is.
Another thing, Sam, I think which is just good for courtesy as well, and good for is the record keeping of it as well on any installation certs, because if this has been recorded years ago and someone's following after the event doing another installation and they're encountering the same problem, they can then see that it's actually been an inherent thing for a while as well. So again, I think always document it as well somewhere, make a note of it, and equally that you've actually informed the customer to make the DNO aware of the situation. Yeah,
but ultimately it's one of those that if you have got adequate fault protection still, so it's not affecting, then we don't need to worry too much.
No.
On the flip side, if we haven't got, then you need to make the customer aware that it's potentially dangerous, i.e. not dangerous right now, but you might not be adequately protected if a fault were to occur, because you're not going to achieve your required disconnection times. So yeah, just again, it's a conversation and an explanation to have with your customer. Okay. We've got some questions coming in now, so thank you for that. We'll try and go through those. There's one comment at the beginning that I'll do my best. So, what are the NIC going to do to combat hideous workmanship from some of their members? Okay. First thing I want to say is this is a technical Q&A, so we do try and keep it technical on a Monday night, but we will very quickly. This is one of those things that we do get, and that there's a lot of frustrated people out there. What we always have to do is, we can't sort of react to one electrician talking about another electrician's work. What we can react to is the customers. So if you've seen something that a member has done incorrectly or not to standard or unsafely, then encourage the customer and perhaps help the customer to document what the issues are. but we will react to that customer's formal complaint. We'll then get involved in investigating it to see if there are areas of unsafe installations or non-compliance. But what we can't do is we can't react to electrician A phoning up and saying that they've just been somewhere where they've seen electrician B work and it's not to standard. We do need to have that customer involvement, and we need it formally recorded as a complaint, which they can do either through the website, or we can actually send them out a form. So by all means help them to document what you believe the concerning issues are, and then we will react. You know, we do react to that. I've got a guy from the technical helpline team going to a site tomorrow to actually investigate one of these. So it's something that we do take very seriously. You know, we do everything we can to uphold the standard that we stick to behind our schemes. So yeah, we do react. Would you add anything to that, Dan?
To be fair, you know, obviously in the whole east of England, I come across complaints and issues which we do review. I review them personally as well. I've been out many site inspections as well as my area engineers as well, to actually, you know, view cases where there've been reports of, say, poor workmanship. As you say, we do take it very seriously, and we do a thorough investigation. But we do base it on evidence as well. It is you know, quite important that we have that evidence, and as you say, we need the customer's involvement as well.
Yeah. Okay, another comment: too much domestic talk now when it comes to regs. Well, you know, we'll answer what we're asked, you know, and a Monday night is open to all. It's not just for our registered contractors, so we will try and answer. If you have got non-domestic questions, we will do our best to answer those to you. Perhaps a non-domestic question just below yours as well. So there's another engineer who said, where do you find the max earth fault loop impedance values for MCCBs? Okay, MCCBs are manufactured to a British and European norm standard. The difference, though, one of the differences between that standard and the standard for breakers is that the maximum ZSs can be different for each manufacturer. So there's no thresholds that are constant across all different makes for a particular rating. So when it comes to MCCBs, you do need to go back to the manufacturer to get details of maximum earth fault loop impedance. Generally, we don't ever have problems. We find that they will all provide it. We tend to not have everything that we keep on the helpline just because there's too much data. So you might have a better response by going directly to the manufacturer. Agree with that as well, Dan?
Spot on. Every time I came from an industrial background, always went straight to manufacturer, and there's a couple of well-known manufacturers out there that have got fantastic and excellent technical databases, and if you give them the model type of the MCCB, they'll go to you rings data on it. And to be fair, and for each setting of the MCCB as well, different ZS values, so they go proper into it, and you know, you can really get exactly what you need. So again, manufacturer data, internet is a wonderful thing.
Okay. Question from another engineer. Evening guys, is an unswitched fuse spur acceptable in a wet room for an extractor fan? Okay, we would need a little bit more information because whereabouts in that wet room, inside the zones or outside, but potentially yes. I mean, the fact that it's unswitched would mean you could get it a bit closer, but it would we'd need to know exactly where you were thinking of, because it would need to make the IP rating for if you were to put it in zones, and even outside of the zones. So if once we go outside of the zones, we may not have to consider section 701 anymore, but we still need to consider general regs, and general regs would tell us that everything we install has to be suitable for the environment in which we install it, or the way that we install it makes it suitable. So yes, you could install it, but a little bit more information about where exactly you were thinking of installing it, in particular if it were in one of the zones, which zones were you thinking about, and we'd perhaps be able to give you a definitive answer then. Okay, some of the other engineers responding to the previous one, which is really good. Thank you very much for doing that. That's the whole idea of a Monday night. So yeah, there's engineers saying go back to manufacturer's data, and engineers saying that the highest reading from all outlets if supplying steel. So yeah, I think we would definitely go back with the maximum rating. Somebody mentioning Schneider Technical, give them a call. Obviously, if it's a Schneider product, then that would be it. Okay, and contact the manufacturer. So no, that's really good. Your on-site guide will have a table to work it out. Well, yeah, you can. You'll be able to work out a maximum value based on the rating of the device, but the ZS of the device might actually have a wider tolerance than that. So strongly go back to the manufacturer to get the right equipment. Check meter with another if still high, report to DNO. Yep, so I think that's responding to one of the earlier questions, which is spot on. Okay, one that's come in. What code would you give a TT system with no 100 milliamp main RCD switch and single insulated tails installed? Okay, so what we haven't been made aware of from the question is, although we haven't got a 100 milliamp main RCD switch, are all the outgoing circuits from the consumer unit or distribution board RCD protected, and can all the outgoing circuits meet the maximum ZS of the associated RCD to achieve disconnection times? Because there was a little bit of a fallacy that you even if you protected all of the outgoing circuits with perhaps dual RCDs or maybe even individual RCBOs, you still had to have a 100 milliamp main switch to protect the internal cables of the distribution board or consumer unit. That was something that was I don't want to say specified, but it's the first word that's come into my head. It was something that was specified by others, not by us. So the NIC view always was that providing the outgoing circuits were adequately protected, RCD protected, and providing the incoming tails, the double insulation of those incoming tails was maintained until those tails were inside the enclosure, then you didn't need to RCD protect the tails. It was understood that there were single insulated tables within the enclosure, but the fact that they were within an enclosure meant that they were, as long as they were secure and not under stress or strain, they'd be adequately protected by single insulation within an enclosure. So in response to your question, what code would you give a TT system with no 100 milliamp RCD switch and single insulated tails? Okay, there's one thing. If they were truly single insulated tails outside of the enclosure and they were accessible to touch, then we'd be recommending a C2. If they were double insulated tails and the tails were brought into the enclosure and then all of the outgoing circuits were adequately protected, even if the main switch was just a main switch and not RCD protected, we would suggest that there's no code required, because there's no danger or potential danger to the users of the installation. So it was a common one, wasn't it, Dan, that people were under the impression that you had to have 100 milliamp RCD to protect the internal wiring between the incoming supply and the outgoing circuits.
That's right. So you say if your double insulated tails terminate all the way into the incomer, that's fine. If they were single insulated, then obviously then you've got an issue. But if they're double, then it's say no code attributed for all the outgoing circuits all protected by RCD. So yeah, no, agree with there, Sam.
Okay. Another one that's come in. How do you bond a removable metal handrail in a commercial swimming pool? The supply is TNCS. So a removable metal handrail, that's going to be extremely difficult to bond if it does require bonding, because you wouldn't foresee a practical solution of somebody being able to disconnect a bond to make it removable. I think it might be more of a consideration to try and make that a bit of isolated metal work so that it doesn't need bonding, i.e. Prevent it from being extraneous, prevent it from being able to introduce a potential, or perhaps actually exchanging it for a material that's not conductive at all, so again it wouldn't be able to introduce a potential and therefore wouldn't be considered extraneous and need bonding. But yeah, I think I can't think of a sort of a BS7671 solution. It's more of an engineering solution to try and make, remove the possibility of that being extraneous and therefore remove the requirement to bond it, because if it's going to be removable, you can't. I can't imagine that you'd have a solution where either the bond remains or the bond is disconnected. Any thoughts on that, Dan?
I was thinking about changing the material altogether, as you say, an insulated handrail instead of a metallic one. But as you say, we'll put an insert in and say make it, non-extraneous. So
yeah. Okay. Is supplementary bonding still required for a lighting circuit in a bathroom without a 30 milliamp RCD when measurements satisfy 50 volts divided by IA? So if we go in principle, where we haven't got 30 milliamp protection for the circuit serving the bathroom, then we would need supplementary bonding between simultaneously accessible extraneous and exposed conductive parts within that bathroom. So that would be the first question. Are there any simultaneously accessible exposed and extraneous conductive parts? So could I go into that bathroom and perhaps touch an extraneous conductive part and a metal part of the light fitting at the same time? Because if I can, then you would need supplementary bonding in the absence of 30 milliamp RCD protection. So yeah, that would be a 7671 requirement, because otherwise it would be non-compliant. So yeah, if they're not accessible or simultaneously accessible, perhaps you've got your extraneous conductive parts boxed in, it's a class 2 light fitting, so there is no exposed conductive parts, then you might be able to risk assess to determine that there's no simultaneously accessible conductive parts. So that is a caveat that's acceptable, but you would need to do some investigation to ensure that that's not true, and you might find it actually easier to add the supplementary bonding. Any thoughts on that one, Dan?
Just say really about mitigating the risk, if it is simultaneously accessible. But I say under normal circumstances, you either have RCD protection of all the final circuits serving the location, or supplementary bonding. So in the case that you haven't got either, then can you mitigate the risk, which we already alluded to? So
yeah. And so next one, obviously type A RCDs or RCBOs will become pretty much standard now on new installs. When adding a new circuit to an existing install, should we be changing the existing type AC RCDs RCBOs to a type A? Okay, so when adding a new circuit, if your new circuit, either the circuit itself because of its location, or perhaps the wiring system associated with your new circuit needs the additional protection of an RCD, then you're going to need to comply with current regs for that RCD. And if we do go to Amendment 2, which we can use now, we will be using from 27th September for all new work, that would that clearly states that unless you can confirm that the load isn't going to generate any DC leakage current, then you must use a type. Well, you can't use an AC unless you can confirm that you've got a load which isn't going to generate any DC leakage. So that's really clarified if we go to an Amendment 2 install. If we stay with Amendment 1 or original 18th install, then you've got the option, but it's really is one of those things, kind of as you've inferred in the first part of your question. If you want a future proof as best you can new install, then you would be looking at a type A, but perhaps what would really make it clear and clarify it for you as the designer would be a little bit of investigation into what you're going to be supplying. What's that circuit going to be supplying? Is it an item of equipment that could generate DC, in which case yes, I'm going to require an A or perhaps even a B, and then also look back at, if you've got a distributed architecture, have you got another RCD further upstream on the supply side of your circuit, in which case that would also need to be considered in terms of, if you had an A at your remote board, although it would work with DC, it doesn't block it, and that DC could go back further upstream and cause issues with a type AC on the supply side of your circuit. It's a common question, and I think as the engineers implied, I think in the future going forward we will see sort of ACs slowly being redundant, and you know, A will become the standard. Would you agree with that, Dan?
Totally. As I say, to be fair, as I say, the current Blue Book, general purpose RCDs can be the type AC, but you go to the Brown Book, it says where it's known that there are no these components, then yes, you can use a type AC RCD. But if it's likely there isn't really these components, then you've got to go to type A, and it is a regulation. So yeah. And I think moving forward, type A will be the new standard for the current requirements, and that may change in the future as load characteristics change as well. But just definitely moving forward. And in other countries, it's, you know, they're already ahead of the game that way, and it's all type A anyway. And some countries, as you know, they're not actually committed to fit type AC. So
okay. Recently called out to a property because they had lost power to socket outlets. Found old rewirable Wilex fuse carrier burnt out rather than blowing the fuse. On further investigation, there's no main earth on a TNS supply and no main bonding at all. Contacted the DNO to let them know on behalf of the customer, but I've not heard anything since. Obviously the fuse wire did not blow because the earthing issue. Is the DNO liable to supply a main earth, or have I got to install an earth rod with upfront RCD protection, etc.? Cheers. So yeah, a really good question, and perhaps a little bit more common than many people realise. The situation is, if we're talking about an existing installation where the DNO have supplied an earth in the past, then they have a duty under their supply and quality regs to maintain that earthing system. So that's one thing to say. If we're talking about a brand new installation, or an installation where they've never supplied an earth in the past, then they have no regulatory requirement to provide you with an earth, and they can refuse to provide you with an earth if they choose to. So it really does take a little bit of investigation. I know that's not always easy, because, you know, if you ask the homeowner where are their certificates, they'll say, you know, they'll perhaps show you their swimming 25 metres and their cycling proficiency, but they've got no idea of any previous installation certificates. But if you can demonstrate that the DNO has provided an earth in the past, then they have a duty under their regulations, which are statutory, by the way, so that's a legal requirement, to maintain that earth. And I think it would be worth perhaps helping the customer to word and frame a letter to explain that just potentially how dangerous the situation is without an earth, because as they've experienced, if we've got no earth fault path, then that fault current obviously was large enough to melt the contacts associated with the fuse. But because there's so it was perhaps just a slight overload rather than a massive overload for a long amount of time, because there was no earth path for that fault current to dissipate to. So yeah, that would be concerning, because that same current is flowing all around the installation. So anybody touching a piece of metalwork which is, for want of a better phrase, earthed, could potentially come into contact with that fault current. So yeah, a little bit concerning. But go back, see if you can find some evidence that the DNO have provided an earth in the past, because if they have, then they've got a duty to maintain it. Your alternative always is to TT it, but then that's involving a bit of work up front, because you've got a sinker rod. You perhaps might have to provide additional RCD protection for some of the circuits that may currently not have it. And of course then you've got an ongoing issue of, now that you've created an earth, you've got to maintain it, or that the homeowner's got to have a regime in place to maintain it in the future. So that is always an option that you could take, perfectly acceptable. But yeah, perhaps consider or ask the customer if they want to consider going back to the DNO, because they do have a duty of care if they've provided an earth to the installation in the past. But yeah, a difficult one, isn't it, Dan?
Yeah, no, spot on though. As I say, he's going back to find out if DNO are responsible for maintaining that connection, if it's there pre-existing, they do have under the SQCR to maintain that. Otherwise, the go-to response a lot of the time when they don't is to make it a TT, as you say. So definitely worth investigating further.
Okay. Right, we've once again gone mad. So we'll squeeze one last one in. Another helpline classic. So on an installation with a number of double insulated items of equipment, should I tick the double insulation box on the schedule of inspections? What's our advice there, Dan?
Common one, find a lot of the time. The answer is generally no, unless the whole installation or circuit is intended to entirely consist of double or reinforced insulation, for example. So yeah, generally it's actually no. And if you go to actually section 412 and regulation 412.1.2, it does actually say where that is actually to be the sole protective measure, that it should actually be under adequate supervision as well. So you're not really going to find it. It's not going to be a commonplace thing that you're going to find all the time. You will find it sometimes, but not all the time. But generally, it's no. It's for the whole circuit or the whole installation. So if you've got an insulated sheet cable, for example, but feeding class on equipment, and obviously it's no. But you got to have the whole, source, the cable, the each end of the cable, everything's class 2 to be considered for that.
Yeah, absolutely. So it's rare. And one thing is, if it is being used as the sole protective measure, then that installation or that circuit would be required to be under effective supervision in normal use. So it can only be put in place in that area. Okay, few bits of information to pass on. The first one is that we first of all, thanks very much for those people that have, all of you that have participated tonight, in particular the people that have posted questions in, and also those that have responded to some of our question posts to help each other out. That's really great, fantastic to see, and it's literally the whole idea of this evening, so that's really good to see you doing that. Tonight's our last Q&A for a little while, because although we normally run them every 2 weeks, we're actually going to be taking a summer break in August, so there'll be no more Q&A sessions during August. There will be more live Q&As coming back in September, when we'll also be restarting our wire series of webinars. So please keep a lookout on the NIC website for those coming up, and you'll be able to enrol on those in early September to book your places. During August, please keep in touch with us. We will still be active on all of our social media channels, so Facebook, Twitter, LinkedIn and YouTube. We will still post our question of the week out through social media, so you'll still be able to do that. Also, as Dan talked about earlier, we've recently launched our pocket guide app. So our traditional pocket guides have all been updated and turned into a nice, usable, readable app. We've also added some calculations in there. So of course we had to put the adiabatic equation in, our absolute favourite, that's in there, but we've also got some handy calculations for calculating design current, also some sanity checks when we're doing resistor measurements and trying to equate that to length of cable runs. So yeah, it's a free app that you can download, available for both iPhone and Android. So yeah, if you haven't already, please go and download that for free and have a look at it. Just getting some information here in the chat, and I'm going to pick that one because it's perfect. Pocket Guide is super, with a big thumbs up and get it. So that's an absolute fantastic advert for the app, really good. Thanks very much for participating. I think my picture might have froze. That's what some people are telling me, but that's fine. I wouldn't have got.
It's me that I could see. I've got a problem my end, so no, I'll just see you frozen.
I think I've frozen, but that's no. You know, believe you me, I don't look any better when I'm moving about anyway. So it's absolutely perfect. So thanks very much. It's been a real scorcher in lots of different ways today. So yeah, enjoyed that, Dan?
Always. Or do you know what? I think you alluded to earlier. It's just always nice because I can't see the comments, but it's nice to see like everyone helping each other out, and so that's what it's about. Sharing knowledge, sharing experiences, and it's just really nice to see everyone joining in. And it's nice to get the positive feedback from the app. I personally love it. I've got downloaded on all my devices, obviously, and they say the calculation is a really handy tool as well. So I think I'm a big fan of the app, but I am biased anyway. But no, it's nice to see that others are finding it a useful tool as well.
Yeah. Talking about for a long time, and you know we finally, well, it was quite apt in terms of timing. We knew Amendment 2 obviously was coming, so some of the things needed updating. We took the opportunity to update them and also add the calcs, and yeah, we're really pleased. It's been well received. If you do spot something that's missing or something that you think would be a good idea, you know, an added value, then please let us know. And one of the things is, now that it's on an app, we can, you know, make dynamic changes. So it's something that we would consider if we see that there's a benefit for all in doing it. So really good. Okay, well, I think everybody deserves a cold drink of some sort for making that through today. Apparently it's going to be just as hot again tomorrow, so yeah, I hope everybody stays safe. Thanks very much, Dan. Fantastic as always, really good. And thanks to everybody out there. Have a great break. I hope you get a chance to get away, and if you know, plenty of reading out there. Please do look out for us on social media over the next month, and keep your eyes peeled on the NIC website for the subjects that are going to be the new wires starting in September. Okay, thanks very much.
Take care all. Have a good evening.